Number 1. Apply the transformation M to the polygon with the given vertices. Name the coordinates of the image points. So we're going to have new points A prime, B prime, and C prime. So we're multiplying all the x's and the y's by 4. So what do we get for our new A? 1240. What about B? Negative 24, 16. And C? Negative 4, negative 16. Just looking at this here, what type of transformation is this? Dilation. And we describe it by the scale factor, which is 4.
Are you going to have to, if you ask you a question like that?
If a question on the test asks you to identify and describe, you need to tell me what the dilation is and what the shape is doing. So when it's a dilation, you tell me the scale factor. If it was translation, you tell me which way it's moving. Nah. Okay, number 2. So we're going to have new points P, Q, and R. What does P become? Negative 1, comma 3. What does Q become? 2, 7. And R? Negative 4, 5. So this one we're subtracting 2 from the x and adding 6 to the y. So what type of transformation is this? Translation. And how would we describe the transformation?
Going to the left and then going down.
So we're going to the left 2, because remember, x tells us left or right. And y tells us up or down. So we're going to the left 2 and up 6. So let's look at 3. Prove the triangles are congruent. For this one, it's supposed to be 6, negative 9. So how do we go from negative 1 to negative 3? So we could subtract 2, but does that work for our next x? If we subtract 2 from 1, do we get 3? No. So that doesn't work. So we need to try something else. We can multiply by 3. Does that work for the next one if we multiply by 3? And the next one?
You can do it anyway. It doesn't have to be added.
Right, we can multiply. So we go from xy, and now we have 3x. And what about for the y? How do we get from 2 to 6? What do we do? Multiply by 3. And that works for the next one and the next one. So our transformation is 3x, 3y. What type of transformation is this? Dilation. Are dilations congruent? No. So this would be not congruent. Remember, in dilation, we're taking a shape that looks like this. And in this example, we're multiplying it by 3. So we're making this 3 times bigger than it already is. So is this triangle congruent to this triangle? No, they're 2 different sizes. So in dilation, it is not congruent. Okay, let's look at 4. Prove the triangles are congruent. What do we do for this one? Casey. So we're perfect. So we're switching the positions. We're taking y and putting it in the first place. And we're taking x and putting it in the second place. We also have to make x negative. So we're going from xy and making this y, negative x. What type of transformation is this? Rotation. Are rotations congruent? Yes, so this is congruent.
Is this gonna be posted on the others? Are we gonna have to know that it's gonna be like counterclockwise?
No. Okay, let's look at 4.2. Classify the triangle by its angle measures. So what would be the first one on the top left, Nicole? Obtuse, perfect. What about the one right below that? Equiangular. And the one on the top right? Acute. And the bottom right? Right triangle. Perfect. Now let's classify the triangle by its side lengths. So the top left, Ryan, what'd you get for that one? Isosceles. And the bottom left? Scalene. And the top right? Equilateral. Okay, let's look at 6. Ton, what'd you get for 6?
I got x equals 80.
How'd you get that?
So 3x plus 20 equals 180.
So 3x plus 20 is just talking about one angle. So if this is an equilateral triangle, because all the sides are equal, what do the measure of each angle in an equilateral triangle have to be?
All the same.
They're all the same, but what degree is that, Robbie? 60. So in an equilateral triangle, every single angle has to be 60 degrees. So if this angle here on the bottom left is 60 degrees, we would set 60 equal to 3x plus 20. And now we solve for x. So we subtract 20 from both sides, and we get 40 is equal to 3x. So x is equal to 40 over 3, or 13.3.
But we didn't get like decimals on our.
No, you'll get nice even numbers on the test. No. Because this is an equilateral triangle, and in an equilateral triangle, all the angles are 60 degrees. Yes.
Can you like a scaling triangle or something? Would you put it to 180?
Well, in a scaling triangle, we would need to know more than just one angle. So if we had a scaling triangle like this, and it gave us like this angle, this one, and this one, we would add them all up and set it equal to 180. So in this example, we have one angle here that's 3x plus 20. So we can add, another way to do this would be 3x plus 20 plus 3x plus 20 plus 3x plus 20. Because we know that all three angles are 3x plus 20, and set this equal to 180, and we can solve that way. Okay, let's look at number 7. What is the value of x if the acute angles of a right triangle are x and 2x? Casey. Perfect. So remember, the acute angles of a right triangle will add to give you 90 degrees. What is the measure of angle B in number 8? How do we find this? Alex.
3x equals 6x minus 9.
3x is equal to 6x minus 9. So we know that these two angles are going to be equal to each other by the third angles theorem because we have two pairs of congruent angles. So we know that that third pair of angles is also congruent. So we just set these two equal. So we have 3x is equal to 6x minus 9. What'd you get for x? 3. So it's asking us for angle B. So we have to take this 3 and plug it in to B. So what do we get for angle B? 9 degrees. Number 9, what is the measure of the smallest angle of a right triangle if the second smallest angle is 56? Casey. 34. So we know that we have a right triangle here. So one of the angles is going to be 90. Our other angle is 56. We need to find that third angle, so we can just call it x. So we have 90 plus 56 plus x is equal to 180. So what's 90 plus 56? 146. So we subtract that from both sides. And we get x is equal to 34 degrees. So number 10, find the value of x. Sarah, what'd you do for number 10? 2x plus 2x is equal to 100. Perfect. So we see that this angle is congruent to this one. So we know that this angle on the bottom right is also going to be 2x. So the exterior angle is equal to the sum of the two interior angles. So we add the two angles on the inside and set it equal to the exterior one. So we have 4x is equal to 100. And what'd you get for x? 25. Perfect. Okay, number 11. If triangle ABC is congruent to triangle XYZ, which segment is congruent to segment ZX? Casey. Segment CA. Perfect. We could also call segment CA segment AC. These are both right answers because we're talking about the same segment. So this is just two ways to name the same segment. What about for number 12? Which angle is congruent to angle Y?
B.
Angle B. Perfect. How would we find number 13? How would we set this one up? So we would set 30 equal to 2x plus 4 because we know that angle B is congruent to angle Y. So we set them equal. Then we solve for x. So what do you get for x? X is equal to 13. And for 14, we do the same thing. So we know that segment BC is going to be congruent to segment YZ. So we set them equal. So we do 35 is equal to 3x minus 5. We add 5 to both sides. And what'd you get for x? When we add 5, we get 40 is equal to 3x. Then we have to divide by 3. So we get x is equal to 40 over 3, or 13.3. 15 says, what is the measure of angle B? But if you look, there's no angle B. So let's just find what x is. So how would we start this one? Ariana.
Do the two sides equal to each other?
So we set them equal. We know that this angle is going to be congruent to this one because of the third angles theorem, so we can set them equal. So we have 3x plus 4 is equal to 2x plus 18. So now we solve for x. What'd you get for x? Anybody? 14. Did anyone plug x back into the angle? What'd you get? 46. So this angle is 46, and this angle will also be 46.
If we were solving for B.
Yeah. Any questions from this page?
The last time we just did, if there was a B, like, to solve for where we...
It would have to be like angle, if this was A, B, C, it would have to be called angle ABC. So I would be talking about that. Ready for the next page? Which value of x proves that triangle ABC is congruent to triangle XYZ by side, side, side? How do we set this one up? Robbie.
We do 12 equals 2x minus 1.
Perfect. And what'd you get for x?
I got x plus b.
When we add 4, oh yes. So x is equal to 8. Perfect. So if we're using side, 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 we need 3 congruent sides. So we're saying that this third side is congruent to the third side. What value of AB proves triangle ABC is congruent to triangle XYZ by side, angle, side? Nicole. 17. What'd you get?
17.
Perfect. 17. Let's look at 4.6. Which postulate or theorem proves the triangle is congruent? So we have one pair of congruent angles here, a pair of sides here, and another pair of congruent angles here. So what theorem or postulate can we use for this one?
Oh, wait.
Casey. ASA.
Number 17 was 17.
Yes.
It's ASA because it's ASA.
Because the side that we're talking about, this one here, this side that's congruent to this side, is in between the two congruent angles here. So that's why this S has to be in between the two A's. So we're talking about the included side, which is the one in between this angle and this angle. So let's look at 19. Which postulate or theorem proves the triangle is congruent? Francisco, what can we do here? Okay. So in this picture, what else do we know? We have one pair of congruent angles here and one pair of congruent sides here. What else do we know from this picture? Casey.
Where the angles that the two triangles touch, they're congruent.
How do we know that these two are congruent? They're vertical angles. So we also know that these two angles are congruent because they are vertical angles. So here we have one pair of sides that are congruent and two pairs of angles. So what, yes. So we have two angles and one side. But that side is not in between the two angles. So AAS. So we have an angle, and a side. But that side that we're talking about is not the included side in between those two angles. So it's not in between the two A's. Okay, 20. Which postulate or theorem proves the triangle is congruent? So looking at this picture, we have two pairs of congruent sides. What else do we know here that's not already marked? The middle is congruent. How do we know that that middle line is congruent on both triangles? The reflexive property. So now we have three pairs of congruent sides. So what postulate or theorem proves these triangles are congruent? Side, side, side. Any questions on anything from this page? Ready for the next page? Which postulate or theorem proves the triangles are congruent? So we have an angle, a side, and an angle that's congruent to an angle, a side, and an angle. So what can we do here?
So since it's angle, side, angle, and the side in between both angles is ASA.
ASA, perfect. Because that side is in between the two angles that we're talking about. For 22, which postulate or theorem proves the triangles are congruent? HL. Because we have a pair of congruent hypotenuses here and a pair of congruent legs here. And they're both right triangles, so this is HL. What additional statement is needed to prove triangle ABC is congruent to triangle XYZ by angle, angle, side? We need another angle. Which other pair of angles can we say that are congruent? So we already know that X is congruent to A. So what's another pair of angles that we can say are congruent to each other? C and Z. So we can say angle C is congruent to angle Z. Perfect. We could also say that angle B is congruent to angle Y. That would also be a right answer. Yes. We're saying that this is the additional information we need in order to say, yes, in order to use angle, angle, side, AAS, we need one additional piece of information. So we need that one extra angle. We're not saying that, like, we're not assuming that these are, but we are just saying that we need this in order to prove that these triangles are congruent.
Can't you say that you're not assuming them because it says that the triangles are congruent?
Well, we're trying to prove that they're congruent. So in order to prove they're congruent, we either need to know that B is congruent to Y or that C is congruent to Z. Okay, any questions on these three before we start the proof? Yes. Okay. So in order to use the hypotenuse leg theorem, the two triangles have to be right triangles. So here we have two right triangles. Here. And for the hypotenuse leg theorem, we need a pair of congruent hypotenuses and a pair of congruent legs. So remember, the side that is opposite of the 90-degree angle is our hypotenuse. So this is our hypotenuse, and this one is our hypotenuse, and these two are congruent. So we have a pair of congruent hypotenuses, and then we also have a pair of congruent legs. So this bottom leg is congruent to this one, so therefore we can use HL here. Any other questions? Ready to start 24? Yes. So we need to prove that these two triangles are congruent. Step 1 says that segment SV is congruent to segment UV and segment ST is congruent to segment UT. That's given. It says it right here explicitly in the given. Next step, we have segment TV is congruent to segment TV. This is the reflexive property. So we're saying that this segment in the middle is congruent on both triangles. We know that one's the reflexive property. Step 3 says that angle S is and angle U are right angles. How do we know that angle S and angle U are right angles? Because it says it right here in the given. So what's our reason? Given. Our reason for step 4 says that we're going to use the right angle congruence theorem. Does anyone know what the right angle congruence theorem is? If you have right angles, then they're congruent. So we have two right angles. So what do we know about angle S and angle U? They're congruent. So we can say angle S is congruent to angle U. Step 5 says that angle SVW is congruent to angle UVW, which it's talking about these angles on the outside here. And then step 6 says that angle SVW and angle SVT are supplementary, and angle UVW and angle UVT are supplementary. And this is the linear pair theorem. So we're saying that this angle here is supplementary to the angle inside here, and this angle is supplementary to this one. How do we know that these two angles are supplementary? Because they form a linear pair. We have a straight line here, and we have one angle and another. So these two angles form a linear pair. And then same here. We have this angle, and it's linear pair on the inside. So step 7 says we're going to use the congruent supplements theorem. What is the congruent supplements theorem? So if we have two angles that are congruent to each other, then their supplements are going to be congruent. So we're saying, now we're talking about these blue angles here. So these two angles are supplements to two angles that are congruent. So now these two angles are also congruent. So what can we put for step 7? For statement in step 7? So we're talking about these blue angles. We just said that they're congruent. So SVT is congruent to angle TVU. So we're talking about this angle is congruent to this one. Next we have angle STV is congruent to angle UTV. So this angle here is congruent to this one. How do we know that those two angles are congruent? The third angle theorem. You guys need to know that for your test tomorrow.
Is it like every one before the last one is going to be third angle theorem? It's like this?
Not necessarily. So our last step that says that triangle STV is congruent to triangle UTV. And this is the definition of congruent triangles. So remember, the definition of congruent triangle says that if all the corresponding parts of one triangle are congruent to all the other corresponding parts of another, then the two triangles are congruent. You need to know this for your tests too. Yes, Casey. Yes. 1. So the third angle theorem, I'll do another example. So if we have a triangle here and a triangle here, and we know that this angle is congruent to this one, and this angle is congruent to this one. By the third angle theorem, we know that this angle is going to be congruent to this one because the other two pairs of angles are congruent, so the third angle has to be congruent too. So that's the third angle theorem.
So if two angles are congruent, the other one has to be?
Yes. So if these two angles are congruent to two angles in another triangle, then the third pair of angles have to be congruent.